Hey guys, welcome to Code and Box Automation Lab. This is Sharful. In this tutorial we're going to learn unit testing, like what is unit test, advantages of a unit test, and also how to write a simple unit test with example. Okay, so let's go. So first things, what is unit test? So unit testing is a type of software testing where individual units or components of a software are tested. The purpose is to validate that each unit of the software code performs as expected. Unit testing is done during the development, like during the coding phase of an application by the developer. Unit tests isolate a section of code and verify its correctness. A unit may be an individual function, method, procedure, module, or object as long as it's independent. So in software development lifecycle, unit testing is the first level of testing done before integration testing. Unit testing is a white box testing technique that is usually performed by the developer, but nowadays QA developer also doing unit test, especially the QA automation developer. Okay, so it is now transforming unit test from developer to QA, but mainly still it's a developer are the main responsible for doing unit test or white box testing. Let's say in a real life example. So think about a e-commerce site where there is a login function, okay, and in a login function you have different method to log into your applications. So it could be by user, your username and password. That's one combination. It could be login by Facebook, could be login by Gmail, and etc. So if we break down this login function, like username is a one component, it's an independent one component, its a password is another independent component, and both this works together. So your unit test and the other hand, your Gmail or logging through Facebook, that's another individual component. So your unit test could be you just test your functionality of this username, like the method, a specific method written for defining this username or defining the password, or if this username and password is not independent to any other component, then you can do a unit test together this username and password as in one combination or a unit. But you can do individually username and password, but over here I think so it's possible you can do a unit test combining unit, username and password. But a lot of people, they prefer just to do a unit test is for a username. So because this is the most the small part of this login function, that just a username, this is one of the pure independent component that it doesn't depend to any other function, any other part. So you can do, and sometimes you can together because username and password works together. But login through Gmail, this is a whole different component for the login function. So you're logging through Gmail, that will be another separate unit test. So logging through the Facebook is similar. So that's the way you can define a unit. It means very independent component of your function, of your application, or of a method, or could be an object of your application. So this is the very simple example of unit test. So when the developer, they write a code, for example this username and password together, you can do a unit test for this username and password together, or you can do a unit test for username first and then you can do another test for the password, just to make sure the code is being written for this component, it's correct, the logically it's right, okay, and it's working as expected it. Okay, now let's see the advantages of unit testing. The main advantages of unit testing: when you add more features to any software, you might need to make changes to the old design and code, and this can be expensive as well as risky. if you use the unit testing methodologies, then this can save a lot of time and can make the whole process much faster and easier. So here is the main few of the advantages you can highlight, like quality of code, find software bugs easily, facilitates changes, and reduce cost. So if we think about how unit test can help to quality of code, so unit testing significantly improve code quality. It helps developer to identify the smallest defect that might be present in the unit before it goes to the integration testing. Okay, and the next one is like find software bugs easily. Yes, unit test helps identify all kinds of issues with software at a very early stage. The software developer can then work on these issues first before progressing any further. The main advantages of this when the issue are resolved at an early stage. Definitely, when its issue is resolved, find the issue in the early stage and resolve it. It saves your times, business hours, and your labor, a lot of hassle. So no other part of the software is impacted when it's resolve the issues in early stage. This leads to increased efficiency, reduce downtime, and reduce cost that would otherwise arise as a result of a whole design process scaling. The next benefit is facilitate changes. So refactoring the code or updating the system library becomes much easier when you test each component of the software individually. If there were any problems, they are detected earlier on. The making changes to the system thus becomes much easier. The accuracy of each unit is very verified before it moves to the next phase. So that means that the unit is proven to be in a proper working order before it's integrated with other modules. Definitely, when you find the bug in the early stage and through the unit test, and think about like if you find the bug in your regression stage. So regression it's your whole system. So definitely it will cost more and the problem to resolve the bug other than you find the bug in earlier stage. So next is cost. Okay, it's a reduce cost. So you can easily understand like any problems or bug in the system are identified in the early stage through the unit testing, and because of the cost of bug fixing is significantly reduced for sure. If these bugs are discovered later, then it will be much more expensive to fix them, as I said, even in a production stage or even in a regression stage. Nowadays, in Agile, the regression is very very short window. So at that time, if you find very critical bugs, definitely it will cost. It may prolong your release. You have to change your release cadence, and then it will increase your cost, your business hours. So definitely, it's early stage of finding a bug through the unit testing is one of the really benefited options, and that the developer can perform, or the QA who's doing the unit testing. Okay, so next is unit test example. It means how you can do a unit test, because we know this unit test is a white box testing. It means the developer mostly they perform the unit test, and it is verifying, defining, or finding the bugs, the code the developer writing. So it's not an easy straightforward testing like we do other automation. So how you can do unit test. So to make it very simple and understandable, the unit test, how we can unit test to find the bug in a developer code, we'll see an example. Okay, so let's go to our Eclipse. So here in Eclipse, I have a very simple project which is a unit test demo over here, and it's based on Maven. Okay, so Maven test engine is the framework. So I'm using this project is using the Maven. So whoever, if you're familiar with the Selenium based on Java, definitely you know this. Mostly we use the Maven as a build project management tool. So this project is based on Maven. I hope that you understood that. And as you know, in a Maven, we used there is a pom.xml file where your all dependency here. Let me open it. Okay, so here is the pom.xml file. You can see here is the only one dependency that I use for JUnit. So JUnit is the framework, that's for doing the unit test based on Java, using the Maven, your project management tool. And then here is the version. This is a little bit older version. You can have the the newer version if you can directly either download, or you can use the code from the Maven repository. So use the up-to-date version, but this is the one version I'm using long time, so that's okay. It's totally up to you. So this is the JUnit, the framework. So let's go to, and as you know, it's for Maven project, you will have a two main section, which is one is source main Java, so where you will have your actual code, your related the code, like a development code, and here is another suite, or you can say it's a source test folder. So source test Java, where you will have your test code, right? So all of the classes related test is going to come over here, and all of the code related with your code or development will go underneath source main Java. So in source main Java, let's close it. So source main Java, I have a class. I create a class, simple calculator, so this is a class, simple calculator, you can see over here. And that this class have a very simple addition method. Okay, so you can see very simple addition method, just taking two parameters, which is a and b, and returning after we do the addition, a plus b, return this. So assume that this is your code, like you're building an application which is the calculator, and this is one of the function of that application. So this is your code, and you want to write some unit test to verify this code. Okay, that's our objective. So underneath source test folder, I create another function, another class. It's called simple calculator test. Since I use the class name test, it means this is the test class. So over here I create a class. It's a simple calculator class. So first we're going to create a test method. So as you know, in a Maven, right, we can use a all of your test method, all of your test cases would be just your method, right? So I'm going to create a simple public method. So public, let's say I'm saying void. Okay, public void, I would say. So for this method, like addition method, I will make a very simple test case that will be, I will pass 2 plus 2, then it will be returned supposed to 4, and will make an assertion. So that in that time, since this method will return assertion, so it will not return anything, so that's why it's a void. So here I will give a name of the method is 2, I would say plus 2 plus 2 plus 2 should equal 4. Okay, this is the method name, and then this is the body of the method. And here, so we have to create an object to call this method, like addition method, in this over here. Then we'll pass the argument, right? So I have to call this method. I have to create an object of this class. I hope that you all know about this. You can either you can extend, make a child inheritance. You can make a relationship between as a child and parent, or you can create an object of a class to call any parameters or any method properties from that class. So for this simple calculator, I will create an object. So that's to create an object of a class, all you have to use new, and then that's class name, right, and then puts in a variable. So I will say cal, and then let's put the return. It's the same class type, right? And after that, now I can call direct that method by using the cal, right? So cal, this is object reference, use the addition method. I'm calling this addition method. So as soon as you call this method, you see there is a two argument is over here, a and b. So I have to pass the value. So let's pass the value. It's like, for instead of a it's 2, and instead of b is 2, right? So it will passing 2 and 2. So it means if you pass over here 2 over here and 2 over here, so 2 plus 2, it should be return 4. So that's our assertion would be. So as you know, in a TestNG framework, in JUnit or TestNG framework, there is a assertion. We can assertion always use to assert, to do, to verify your between your expected result and your actual results. That's what the test also needs to do, right? Your test have to verify between your expected and actual, and if they both match, it will be pass. If doesn't match, it will be fail. I hope that you all know, whoever expert doing in regular, like even a Selenium or Cypress, that's how the assertion works. And here we're going to call assert method. Assert dot, you can say assert dot assert equal. So assert is an it's a default. This is a class that comes with the JUnit or TestNG frameworks, and in this class there is a lots of method for doing the assertion. So we can use assert dot assert equals. Okay, we can use assert. So here is a assert dot assert equal. You can see integer. Okay, integer, actual, expected, and integer. So let's sorry, this is not the array, so we'll use the assert dot assert equal. Assert dot assert equals, okay, byte, character, integer. Okay, assert dot assert equal, you can see integer, expected, and it's also so here is the expected. So what would be the expected? So expected, we're expecting 4, and then actual. Okay, so what would be the actual? Actual would be over here. So if we call this method from there, let's cut from here and then pass this over here. So right, so when you call this method, the addition method from the simple calculator, this class, and we pass 2 right, we pass 2 plus 2 and 2, so it will be added 2 plus 2 and it will return 4. So it means our expected result is 4. That's what we're saying. So our expected result 4 and our actual result should be 4. So that then we can say this is a pass, right? So this assertion will find out whether it's pass or fail based on your expected and your actual result. And to make this method as our test case, right? To make this method as our test case, so what do you have to do? We have to use @test annotation, and I believe you all know the test annotation. So import over here JUnit library build path. So here is the related library comes over here is JUnit test. So test annotation, I believe that you all know, whoever works on TestNG framework or based on Maven. So there is a lots of annotation we use, like test annotation before test, after test. So test annotation, it's implies that this method that related right after this annotation, the method over here, this method is for test. This is you can say this is a single test case or single test scenario, okay, to validate for this method. So okay, so that's it. So save it and let's run it. So how can you run it? Right click, you can run. There is a lot of it is Eclipse, so you can run from here, or you can run over here, also run as JUnit test. Okay, let's see. Okay, you can see over here it's passing. So let me drag this over here. Okay, you can see JUnit over here. It's saying ran 1 and it's a pass. You can say it's a pass, and there's no failure, no error. So this test is pass. Okay, it's passing. So now let's see, so if the developer, they made a mistake, so over here, say like they made a mistake, like minus, save it. And so you said just think about it, just assume that developer, they by mistake they put this return as a minus b, and this is our actual test cases. So in this case, if we run again, the test case should fail. Okay, you see this test case is now is failing. It's saying failure, it's a 1, and this is, you can see it's not green check, so it's failing. And also it's saying your, like, where is failing, why is failing. It's saying over here, you can see clearly, you can read over here, it's saying expected 4 but it was 0, because we're expecting 4, but in actual, when you call this method and when we pass 2 2, so it was a 2 minus 2 over here, 2 minus 2, so it returned 0, so it didn't match. So it's saying, so when you fail, we'll come over here and it says, okay, this test case is failed, then go back to your actual code, and then you can easily find it. Oh, wait a minute, I placed minus instead of plus, so that's why it was fail. Okay, so then you can fix your code. So that's the way, you can see this the unit test, how help you to find the bugs or find the error on your individual component or your individual the method. So let's go a little bit deep dive on this method. So now what if developer, assume again they made a mistake, instead of plus sign, they made a mistake with the multiplication. They say this is a mistake. Okay, so plus is the original code supposed to be, but they made a mistake with a multiplication. So what will happen if I run again the same test method, right? Just run it. Okay, we see this, it's still passing, it didn't find any error. So, but is that right code? The code is that right? No, the code is not right, because as I said, by mistake they put multiplication, but our test is still made it pass, went through and it was pass. Okay, the reason why, like, one of the goal for a unit test that we write should be that whenever the code is not doing the right thing, at least one of our unit tests should fail. Right now our code is bad, right? We know this, our code is bad. It's doing multiplication instead of adding, but we don't have any unit test, so our unit test is not good enough to test it, and it's not failing. So everything looks great, but it doesn't mean that this unit test is bad. This is a valid scenario, right? If this is 2 plus 2 should 4, so it is a valid scenario for addition, but it does mean that it's a probably good idea to add more scenarios to our unit test suite. So let's add another test scenario. Okay, so if we want to add another test scenario, let's just copy this guy and just paste it here. Let's make another test. So in this case we're going to do 2 plus, probably I would say 7. 2 plus, let's make it 7. So if we do addition, it should equal 9, right? 9. Okay, so we call this, and then so 7 plus 2, it should 9. Right, so we'll say 2 and 7. Right, so save it. Now run it. Here we go. Now see the interesting things. So now there is a 2 test cases run, and one is passed and one was failing. So the 2 plus 2 should 4, this one is passing, but the other one, you can see 2 plus 7, it's failing. Over here you can say it's failing, right? It's a failing. And here you can see the cause, you can see the cause over here. Here you can see over here the reason over here, right? The assertion failed error, expected a 9 but it was 14. Okay, so because if it's the addition 2 plus 7, it should be 9. That's true, but it's saying that we are expecting 9 but it's 14. Then you can come, wait a minute, why this method is returning 14? We're expecting 9. So go back to that method, and then you can say, oh, here a minute, so instead of plus I put multiplication. That's why it's 2 into 7 is 14. It's finding the 14. So let's fix it. Then you can say, the plus, put the plus, and your code fix it. Okay, now again run it. Here we go. Now we can see that the both test is passed, right? So two ran, no error, no failure. So both of them are passing. Here is a 2 test cases. So that's the way you can add more scenarios for a specific test cases, so that it's cover all different factors. So you have to think outside of the box to add more scenarios, so that it's cover all of the edge cases for a specific method or component, so that we don't fall in this kind of scenarios, like if it's a by mistake we put in multiplication and it still will pass if you just do 2 plus 2, right? 2 and 2. So 2, whether 2 plus 2 or 2 into 2, it's our expected and our actual result will match, right? So that's the way you can see, and it's a similar way if you add this another scenarios for this test cases, it will find the bug. Okay, we found the bug over here. It was a multiplication. So that time you can fix it. So you see this, your fix it is applying, finding this bug and applying in the earlier stage during the development phase. So it solved this issue. So if there is a unit test was not practicing, was not applying, so this bug, this multiplication, this bug will keep going on, and probably you would find this bug in a regression test on later on, or sometimes it's a skip even regression and it goes to the production. So fixing this bug on later phase is really high cost. It's cost a lot of money, cost a business hour, and sometimes it's not, and also it's not efficient. Okay, that's why the unit test plays a very significant role, specifically nowadays in Agile, the frameworks. So that's all for the unit test. Thanks a lot. Have a good one. Bye bye.